Okay guys, let's take a look at today's lesson. We are working with systems of conics. Similar to, well, we've done systems of all kinds of things. Systems of lines in Algebra 1. We did systems of polar equations. I mean, we've done all kinds of systems. We're just working with systems in reference to conics. So the one thing that I think is unusual about this that we really don't encounter in the other types is different, basically squareds, x squareds and y squareds and single x's and single y's, just a whole variety of variables that you need to work with, either using elimination or substitution. Sometimes, and I don't actually have an example of this type on here, but we do have on our homework. Sometimes you actually will, if you do elimination, you get the equation of a line, and then you have to substitute that back in. So it's some things are a bit different than we have done before with other types of equations. So let's kind of look at what we have going on here. So for this first one, it wants us to solve algebraically and then graph. So looking at this, we know that that's not a circle because these coefficients aren't the same, so this is an ellipse. So let's get it in standard form so that we can graph it. Alright, so basically we get x squared over 36 plus y squared over 4 equals 1. Okay, and that's kind of a pretty straightforward one. The center's at 0, 0. And then we go out 6 on each side. And then up 2. And then we have the sketch of our ellipse. Now with these, there's no need to draw focuses or any other parts of the figure. You just draw the standard figure because we're just interested in where they intersect. Alright, the second one, let's see, we have an x squared and a y that looks like a parabola. So let's get that in the proper form. So we have x squared equals 2y plus 4. So we need to factor out that 2 because we can't have anything. We have in front of y has to be a 1. We can't have another number in front of there. So we factor out a 2. And some of us had a difficult time with this concept on the quiz, and I know I passed those back already. Some of us had a really hard time with getting a parabola in proper form. So remember, we have to have just a 1 in front of the y, and then I'm going to move that over. So what that does is it tells us where our where this little guy is. The x coordinate of the vertex is 0 and the y coordinate is a -2. So 0, -2. We see one point of intersection already. And this particular one is going to go up, right? Because it's positive a, it's going to go up. And so we just need some points when x is, we already have when x is 0. When y is 0, we could solve. So, because I would like to see where it crosses the x-axis. So we make that 0, so we have 1/2 x squared equals 2. We multiply, x squared equals 4. So x is going to be plus or minus 2. And that's probably enough to be able to get a decent graph. So from the graph, we should, when we work with our system, we should be getting 3 different intersections. That's what it looks like to us. All right. So we have options. Several things that we can do. I'm going to do substitution, but I would like to talk to you about how you could do elimination. You could subtract these equations from each other, right? If you subtract them, what happens to the x squareds? They're gone, and you're just left with y squareds and a y. So you could solve the equation that way. I'm going to actually solve for x squared, I'm going to move the negative 2y over, and I'm going to substitute that expression into x squared. So I'm going to move the 2y over, and I'm going to take this and I'm going to substitute it in for that x squared term. So I'm going to use substitution, but like I said, you could use elimination as well. So that gives me 2y plus 4, and that's squared. I'm putting that, oops, no it's not, because that's x squared. Okay, that is x squared, so it's just 2y plus 4 plus 9y squared equals 36. So that's a quadratic. We just need to get it, combine like terms, get it in normal quadratic form, and we have okay, this one happens to be factorable. They're not all going to be factorable. If they're not factorable, then we have to default to our quadratic formula. I mean, that's kind of what we have. That's our backup. So this one happens to be factorable. And that gives me my 2y values. So once I have my 2y values, I'm going to need to find the x values that go with them. Okay, so I would just choose the one that's easier to work with. It doesn't really matter which one you choose to plug into. Just pick the one that you like and substitute those numbers in. So let's see. I'm going to choose this one right here. X squared equals 2 times, and then we'll sub in the y, plus 4. And so that gives me, once I do my arithmetic, x squared equals 68 over 9. And again, do my arithmetic, I get x equals plus or minus 2 root 17 over 3. Now, we need to stop right here and write those coordinate points. Just listing what x's and y's are is not sufficient to tell us where the solution is. And we get that every year. Students just leave it like that every year and lose points because they don't actually give us the answer. We're asking for where do they intersect, or we want to solve the system. That means we need actual points, the points that they intersect in. So these x's go with this y. So let's go ahead and write them down. You can write 2 in 1, that's fine. So plus or minus 2 root 17 over 3, comma, and that was the 16/9, wasn't it? Okay, that's 2 solutions right there. And you've got to translate it into point form for it to actually be the answer. Okay, then we want to, let's see, we did this one. Now let's work on this one. Let's plug in a negative 2. So x squared equals 2 times negative 2 plus 4. So x squared equals 0, so x equals 0. And that's the one that we actually found on the graph. That was already, we already knew that that one was there. So that is at 0, negative 2. And there's our first example. Okay? Good? Okay, let's go to the next one. So the same instructions apply to this. We need to graph them and solve them. Doesn't really matter which order you do that in. I actually prefer to graph first so I can kind of get an idea of what I'm going to be encountering, but you don't have to. And I graphed the first one first. Let's just jump into the algebra on this one, and then we'll graph it. So I have the same kind of weird thing going on. I have some x squareds and y squareds and y's and x's and x squareds. We can choose elimination or substitution. For whatever reason, I did substitution on this one. and I took my top equation and I solved for x squared. And then I substituted that into the bottom equation for x squared. So y equals -1 minus, and then all of this stuff goes in place of the x squared. Okay. So now what we do is get everything, distribute the negative, get ourselves a quadratic to solve. And that's our quadratic. Not factorable, is it? Can't think of anything. Just 1 times 2 works, and that certainly doesn't give us a 1, so we're going to have to resort to our old friend, the quadratic formula. So y equals, let's see, we have -b plus or minus square root of b squared minus 4 times a times c over 2 times a. What do we notice is happening here? It's going to be imaginary, isn't it? So that means that these two don't intersect, right? If my solution is imaginary, then that means they don't intersect. Well, they asked us to graph, so let's go ahead and graph. We shouldn't have an intersection. Let's see if we do. Maybe we made a mistake on our arithmetic or something, so a graph is always a good double check. So this is that little guy's a hyperbola, center at 0, 0. Basically out 1 in each direction. See, the x is positive, so the little pieces are going to be on the x-axis. Whoops, got a little crazy there. Alright, so we have this. Almost covered up my mistake. Okay, so there's our hyperbola. Now, what is this little guy? This one's going to be a parabola, isn't it? It's got an x squared and a y. So, let's get it in proper form. Let's see, we would want, let's move the 1 over first. And that's actually fine, just like that. Right, because we don't want a number in front of the y anyway. So where is our vertex? Our vertex is going to be at an x value of 0 and a y value of -1. So 0, it's right here. Now remember, this little box is like a structure that the hyperbola is built on. It's not really the curve. So that doesn't mean that it intersects. It doesn't intersect with that point. And this actually is going to go down, isn't it? Yeah, this a is negative, so this little guy is going to go down. And we were right, it doesn't intersect. Okay? We okay?